projectile motion in just 5 minutes. Hey everyone, welcome back to our ongoing series on AP Physics, and today we'll be talking about projectile motion. Imagine throwing a ball towards a hoop. Sorry mate. Anyway, once the ball leaves your hand, it follows a curved path, right? And that is what is called a projectile motion. The curved path it takes, it's called a trajectory, and the object itself is called as projectile. This curved path, the trajectory that the object takes, can be broken down into two motions, vertical and horizontal motion. Horizontal motion, this is the motion along the ground, and there's no horizontal forces acting, so nothing is going to affect that. But the vertical motion, gravity is constantly pulling it down, so that is going to affect the vertical motion. We already learned about how to find out the components of a vector, and in a projectile motion, all you have is some random vector projected at a certain angle. If you don't know how to resolve vectors into components, check this video out. Now comes the most important thing. How do you answer questions on projectile motion? See, either you would be given some sort of information regarding the projectile motion, or you would be given a figure right out of the question. All you need to do is resolve the given vectors into two components and find out what the question is all about and use those equations of motion. If you don't remember equations of motion, take that out once again. Anyways, you just gotta resolve them into components, plug them in the right equation, and you've got the answer. Okay, how about we try a practice problem? Let's see what you got. A gazelle is fired at 80 meters per second from a cannon inclined at an angle of 40 degrees above the horizontal. Wow, people are getting creative with firing things. How long does the gazelle spend in the air? How far does the gazelle land? What is the maximum height that the gazelle reached? This might seem like a lot of questions, but it's just simple. If you break them down, all you need to find out is the time that it spent in air, which is just time, and then the horizontal distance, and then the vertical height. So the first thing that you must do is resolve the vector into two components. And what do you do about that? The horizontal is cos theta, while the vertical is sin theta, and you have the magnitude of the vector, plug them in the equations, and you will get your horizontal and the vertical components. For your reference, the horizontal and the vertical components are going to be 61.28 meters per second and 51.42 meters per second. Do not forget the units. Okay, the first question, time. It's kind of tricky, right? But what if I told you there is a very simple equation that helps you with that? Yes, write this down. Time of ascent or time of descent is equal to twice the vertical component of the velocity divided by the acceleration due to gravity, which loosely translates to T equals 2Vy by G. Very simple, right? Plug in the values and you'll get the time of flight. For reference, that's 10.49 seconds. Let's move to the next question. All it talks about is to find out what is the horizontal displacement. And you can simply use velocity equation, which is just displacement over time. Rearrange the equation and solve for displacement. Try it out and you should get a displacement of 642.8 meters. The important thing to notice is that you use the horizontal component of the velocity, not the vertical component, because you're finding out what's the horizontal displacement. Let's move to the next question. What you need to find out here is the vertical displacement, which is just the height. So use the vertical component of the velocity and use the third equation of motion, which relates the final velocity, the initial velocity, acceleration, and displacement. Now the tricky thing here is that when this object reaches its maximum height, it's going to stop there for a second, which would mean that the velocity becomes zero. So the final velocity is zero. And the initial velocity is the vertical component at which is fired. Plug in these values, solve for y, and you've got the answer. One common mistake that everybody makes is that what do we put for acceleration? This is a vertical motion, which means it goes up, which means the gravity is pulling it down. So the gravity, which is 9.8 meters per second square, and that happens in downward direction, so it's a negative 9.8 meters per second square. Do not forget the signs. And there you go. We're done with projectile motion in less than 5 minutes. If you found this video helpful, a sub would be much appreciated, and let us know how do you feel about such videos in the comment section below. As usual, check the link in the description below for more fun stuff, and I'll see you in another video. Bye.